So what I'll do is set up a Rogue DHCP server, use the same subnet, but allocate IP addresses in this range. This is a range not available on the router. Subnet mask. I'll set a lease time and renew time. Notice, however, for the router, I'm going to specify myself as the router. So ifconfig on Kali shows us this IP address. So that's going to be the router. It's not going to be the original default gateway. I'll leave the DNS server as it is. And then, for example, I'll set the domain to Cisco. So going back to the DHCP server once again, on the router, we set up a exclusion range of this. So I'm going to allocate an IP address in a different part of that subnet to the client. Server ID needs to be that, so I'll set it to that. Click OK. So hopefully the victim computer will get a IP address now. Notice it got 10.1.2.150. So I'll stop that denial of service attack. So that's good. Route-n, default gateway is Kali. So can this PC ping the router? At the moment it can't. Basically this PC, when trying to get to this router, is sending traffic to Kali, and Kali is not forwarding the traffic onto the router. The router has this IP address. The victim host is not able to get to that IP address. So what we need to do on Kali is do something in the command prompt to forward traffic to the right default gateway. So I'm going to use this command, sysctl -w IPv4 forward IP addresses equals 1. And I need to set it like that. So basically, we are telling Kali Linux we'll forward traffic. So let's try that again. Can we ping Kali? Yes, we can. Can we ping the router? I'll just make sure that I type that command right. Before I press enter, notice we can ping the router. It is a bit slow. So let me stop Yersinia at this point. My network is going very slow. So I'll exit out of Yersinia. I'm forwarding the traffic. Notice that's a lot better now. Now that I've stopped the denial of service, the pings are working. But the difference is now the traffic is going through Kali. So what I'll do is start a Wireshark capture. So under favorites, sniffing and spoofing, I'll start Wireshark. I'm going to start capturing traffic. We can see a lot of ICMP traffic from 10.1.2.150 to the router. I'll stop at that ping. Let's telnet to the router. Now you could have used another protocol type, but in this example I want to use telnet. I'm getting connection refused here, and that's a problem on the router. Show run pipe begin VTY. What I'm going to do here is configure the router's VTY lines to enable telnet or to allow telnet. Transport input all. By default on this router, telnet is not allowed. So try that telnet again. Notice I'm getting password required but none set. Let's assume that the administrator doesn't know what he or she is doing. So I'll set the password to Cisco, and then I'll set an enable password to Cisco. A very bad idea. But notice now I can telnet to the router, put my password in, and I've logged in. Type enable, put my password in, I can log in, and for instance type show run. So what's actually happening is that telnet session is going through Kali to the router. So what I can do here is filter for telnet in Wireshark, and what you'll see is a negotiation taking place between the client and the router, and then suddenly you'll notice stuff like this, CISCO, as in Cisco. Enable, EN there, CISCO, there is the enable password. So we saw telnet password and enable password, but what I'm going to do is follow the packets, in other words, follow the TCP stream, and notice there you go. There is the telnet password, there is the enable password. So it was simple as that to grab the passwords from a telnet session because the traffic is going through Kali Linux to the router. Yersinia really makes this process very easy. I implemented 3 hacks here. I firstly did a denial of service attack on the DHCP service running on the router and exhausted all the IP addresses in the pool. Then I set up a Rogue DHCP server so that when a new PC joined the network or this PC rebooted, it got an IP address from the Rogue DHCP server instead of the proper DHCP server. And then I implemented a man-in-the-middle attack because I forced traffic to go through Kali Linux to the router. I did that by setting the PC's default gateway to the Kali Linux host, and then I used a Linux command to redirect traffic through Kali Linux. So in other words, this PC was used as a relay of traffic. Kali Linux really makes this process easy and shows you why it's important to implement security in your network. To stop this, you could implement DHCP snooping.